Okay, we will continue Chapter 10 with Lecture 2, which is covering the Keynesian cross. Now remember, I said I was going to come back to this big picture for each part within this model that we're building, within this framework we're building. And right now we're going to focus on the Keynesian cross. The Keynesian cross is just a simple model in which we use to determine income by how much we spend. Okay, and what it simply does is it tries to equate this, what we call planned expenditure, with actual expenditure. All right, and the point where planned expenditure and actual expenditure equal, we consider to be in equilibrium. Because if we plan to spend more than we actually spend, what happens? Well, we've planned for more than we actually spent, and so, well, we have an increase in inventory. And if we spend more than we plan to, then we'll have a decrease in inventory. And so the difference between planned expenditure and actual expenditure is, well, something called unplanned inventory investment. So within this model, planned is okay, actual is good, and unplanned not so much. All right, so let me go back and make sure I've defined my notation correctly. I is going to be planned investment, so that's how much businesses plan to spend. C is planned consumption, so that's how much consumers plan to spend. And G is government expenditure, and we just assume that's exogenous. All right, so PE is this total planned expenditure. All right, so you could think of that as planned income, all right, or planned real GDP. That's what we want to have happen. And Y is real GDP. It's the actually what happened. Okay? Oh, sorry. That's goofy. So the next thing we need to do is we need to build this C part. So if you think about this, we want to find out what the planned expenditure function is. All right? And that equals what? C plus I plus G. Now we're going to take G to be exogenous. So we still need, though, to figure out, well, what the heck is C and, well, what the heck is I? All right? So that's where we're at right now. And so what we're going to do now is we're going to figure out, well, what's C? So, consumption function. Essentially, we're going to model consumption as a function of something called disposable income. Now, what in the world is disposable income? Well, that's this right here, this y minus t. What is y minus t? Well, okay, so think about it like this. Y is your income. So that's like your gross pay. Right? So you go to work at a job and you get this number on your paycheck called gross. So if you make $10 an hour and work 40 hours, your gross is what? $400. But is that what your paycheck is actually written for? Well, no, not really. What do? They withhold taxes. And that's exactly what we're doing here. So really, the part that's taxes or the withholding, you never had access to in the first place. It was part of your income, but it just went away to taxes, and you don't have any control of it. It's not at your disposal. So we focus on disposable income because we assume that's what consumers use to make decisions. Next, government spending, of course, we said was exogenous. Taxes are also going to be exogenous variables. All right, so these are our two basic policy variables that are going to be included in this model. Now notice we don't have any room in here for money right now. All right, that's not what this model does. We'll get there in a second. So there's no monetary policy variables. The only policy variables that are entering here are fiscal policy variables, so spending and taxing. All right, so right now we're going to assume that the investment function is exogenous, but it won't be forever. All right, we'll come up with something a little cooler later. And so if this is the case, then our planned expenditure function equals, well, this guy right here. We just substitute in the exogenous level of investment, the exogenous level of government taxes, and the consumption function, or I'm sorry, government spending, and the consumption function, and then the exogenous level of taxes, and we've got our planned expenditure function. So, what's equilibrium? Well, the equilibrium condition is when actual expenditure equals our planned expenditure. right? Because if we plan to do more than we spend, well, then we're not going to be so happy. And if we plan to do less than we actually spend, we're also not going to be so happy. So where we're in equilibrium, where we really like it, is where our actual expenditure equals our planned expenditure. So remember that this formula right down here, because I'm going to come back to that when we graph this all out. So let me go ahead and I'm going to graph the planned expenditure function. And there's some aspects to this that are important. So first of all, the slope of this planned expenditure function. What is that going to equal? Well, first of all, I is fixed and G is fixed. So what's going on? The only thing in here that's changing is the consumption function. And so what is the slope of the planned expenditure function going to be? Well, it's going to be the slope of the consumption function. Now, what's the slope of the consumption function? Well, that's how much additional spending I will do if I get $1 more, right? Or the marginal propensity to consume. Okay, so that is what the slope of the planned expenditure function is. There's one other aspect, pardon me, that is important to note, and that's this intercept. And we often call that autonomous consumption. All right, there's one more aspect we want to talk about, and that's this intercept. And we often call this intercept autonomous expenditure. Right, autonomous expenditure. Why do I call it that? Well, I call it autonomous expenditure because, well, that's how much expenditure is going to happen even if we have zero income. All right, if income and output are zero, we're still going to consume something. Right? And you can think we're still going to spend. Right? Well, we think, well, wait a minute. If I have no money, if I have no income, how do I spend anything? Well, there's exactly one class of people in the world who don't consume anything. Yes, those are dead people. But wait a minute. Let's think. So in River Falls, if you go down Cemetery Road and you look off to the one side, you see this big cemetery there, right? Who's populated with? Well, yes, it's populated with what all cemeteries are populated with. They're populated with, well, dead people, right? Well, those dead people are what? They're consuming grave plots, aren't they? Kind of space. So we even have dead people consuming. Right? So, well, we're never going to get past this whole idea of being a bit of a consumer, but we are going to have this autonomous consumption that's just happens no matter what. Next, oftentimes in this model, this gets called the 45-degree line. All right, and while that's perfectly valid, okay, especially if we were in polar coordinates or something like that, you would define that as a vector with a degree of 45 degrees, right? But that's fine. I don't care. It just doesn't make a bit of sense to me economically. All right, it's a line that has a slope of 1 that goes through the origin. Whoop-de-doo. That's great mathematical sense. Doesn't mean a thing to me economically. What it does mean economically, though, and I think a better explanation is, this is the equilibrium condition. Okay? What's the equilibrium condition? It's the place where planned expenditure equals actual expenditure. And that function just happens to be a line with a slope of 1 that goes through the origin. Right? And so that's a much better interpretation for me. I understand that much better when I do it that way. I don't like calling it the 45-degree line, but I have to tell you that because you'll probably see it in other books, maybe even in this textbook, talking about it as the 45-degree line. I might even slip up and call it that because it gets called that a lot. Yep, see? There you go. Now, we put these together, and what do we get? We get an equilibrium condition. And essentially, this point here where planned expenditure equals actual expenditure is our equilibrium. Well, you might ask, why is that? All right, now that we have this model developed and we have an equilibrium condition, we can start asking some questions, like, say, for example, what happens if we have a policy change? So what happens if the government increases spending? Well, we start out here, And then the government increases spending, and that's going to cause the planned expenditure function to simply shift up, right, in a parallel fashion, the exact amount of the increase in government spending. So however much government spending changes, that's how far it's going to shift up from its original position. And now, notice that y goes up by at least that much, but we have a multiplier effect, right? Because this is a sloped line, it's not a vertical line, so the actual increase in y, all right, is going to be more. An equilibrium output is going to be more than just the change in government spending. Well, so why is that? Well, we have an increase in government spending, which causes an increase in income. But that also increases my consumption because income goes up, so I want to consume more, which in turn increases planned expenditure, which will make businesses want to provide more, and so actual output goes up, and it just keeps going until we get to a new equilibrium. So let's take a look at that. So we want to solve for what this change in y is going to be. So we start out with the equilibrium condition. We put everything into change form. Notice that I is exogenous, so it's not changing. And delta G is only changing because, well, that's the exogenous variable we changed. Notice that the change in C has to be the marginal propensity to consume times the change in Y. Well, that's a very close approximation to what it is. And so we get this right here. We collect all the terms onto one side and solve for everything, and we end up with delta G equals that. And solving for delta Y, which is a little more algebra, we end up with what's called the government spending multiplier, which is really important. So the most important part of this is going to be this guy. Right? Remember I said there was this multiplier effect. Well, basically what that means is when the government spends more, that injects funds into the economy and increases other people within the economy's income who spend more, and when they spend more, that increases income, and then that causes more spending, and it's this kind of cycle that goes on and on and on, right? Well, how do we summarize all that? We can summarize all that with the government spending multiplier. So 1 over 1 minus MPC is the this government spending multiplier. Now, you need to remember that because we're going to come back to the tax multiplier in a second. And there's going to be some interesting things that we're going to do to compare the two. So, definition: an increase in income resulting from a $1 increase in government spending. That is what the government purchasing multiplier is. And remember, it was 1 over 1 minus MPC. You want to remember that. So in this model, the government purchasing multiplier equals, well, okay, yes. So this makes sense. So it's the change in income over the change in government spending, or you could think of it as the derivative of income of equilibrium income with respect to government spending, and that just equals that. So, brief example: what happens if MPC equals 0.8? Why do I pick 0.8? Because 0.8 or 1 minus 0.8 is 0.2, and I can do that math in my head, and that turns out to be a multiplier of 5. All right. Next. And this slide really just goes through stuff that we've already talked about, and take a look at it real quick. It's in your notes as well. Just pause the video here if you need to think about this some more. Next, an increase in taxes. Increase in taxes is a little bit different, and the reason why increase in taxes is a little bit different is because taxes doesn't show up in the intercept as much as it shows up in the consumption function. So the consumption function looks like what? Remember, C equals C of what? Y minus T. Now remember, this C right here, that's a function. It's not C times the quantity Y minus T. It's actually C is a function of Y minus T. Okay, you can almost, if you wanted to write something linear, you could write it out that C equals C naught plus C1 times Y minus T. And there, that is times, right? Because that's just writing out this function. Okay? So don't get confused there. But in any event, well, let's keep going. There's our original equilibrium. And now let's increase taxes. And so what happens? Well, we have a shift down in consumption. But does the slope of the consumption function change? No, not really, because that's not necessarily going to affect the marginal propensity to consume. All right? But that's how much, in absolute terms, the function shifts down. But is that how much we reduce equilibrium? Well, no. We can see there's a multiplier effect, because when income goes down, consumption also goes down. Right? And so, again, we have a bigger change in equilibrium output than the change in taxes. All right, so let's take a look at this. Let's go ahead and solve for the change in y, or basically the partial derivative of y with respect to taxes. Okay, notice that I and g do not change. Why? Because they're exogenous and we didn't change them. All right, and so what does that mean? That means that the change in c is going to be roughly equal to the change in y minus the change in t. Roughly equal to it. If it's linear, if the consumption function is a linear function, it will be exactly equal to it, but generally roughly equal. Okay, solving for y, we end up with 1 minus MPC times delta y equals minus MPC times delta t. And keep going. We solve and we get what's called the tax multiplier. And that's negative MPC over 1 minus MPC. Okay, now I want you to remember this formula too. This is very important. There's a couple of things to note. First of all, with the government spending multiplier, it was positive. With the tax multiplier, it's going to be negative. Right? Why? Because if I increase taxes, that's actually contractionary policy, right? That's going to have a tendency to dampen economic activity a little bit. So it should be negative, right? But there's also something else you should note. MPC must be between 0 and 1, right? I can't spend more than my income. I can't really spend less than my income. I can't spend less than 0. It's going to be between 0 and 1. So the tax multiplier in absolute value must be less than or equal to the government spending multiplier, right? The only way they could be equal is if MPC is 1, which is kind of silly because that would assume we don't save at all. Okay, so not as silly in the United States, but it is a little bit silly because we do save some. And, well, so the tax multiplier mathematically must be less than or equal to the spending multiplier. More than that, okay, so yes, we've got that. And here's a nice example. So that's a little harder to do in my head, but not so bad. We end up with, if the marginal propensity to consume is 0.8, we just plug and chug in the formula, and we end up with the tax multiplier being -4. Notice it's less than the government spending multiplier. I'll just notice something else. What is 5, which is what the spending multiplier was when I had a marginal propensity to consume of 0.8, plus -4, which is what the tax multiplier is if I have a marginal propensity to consume of 0.8. Well, that equals what? That equals 1. And in fact, that's the case throughout. It has to be. All right? The two multipliers sum to 1. And to see that, let's just add the two multipliers together. So the government spending multiplier is 1 over 1 minus MPC plus the tax multiplier is minus MPC over 1 minus MPC. And if I add those two together, what do I get? I get 1 minus MPC divided by 1 minus MPC. And that, of course, is just 1. So there's no free lunch, in other words. That's what this little proof here shows. You cannot have stimulative fiscal policy without increasing a deficit. You cannot have contractionary fiscal policy without reducing that deficit. If all I do is sterilize my policy, all right, if what I do is I increase taxes by $10, or I'm sorry, I increase spending by $10, and to pay for that I increase taxes by $10, the two will offset. All right, and you'll have, well, basically you'll have a change of $10 in nominal income. There won't be a multiplier effect if you do that, because the two transactions offset one another. Okay, so the tax multiplier is negative, right? We talked about that. It's greater than 1. Yes, it's greater than 1 in absolute value, of course. And change in taxes has a multiplier effect on income. Yeah, we've got all this. And it's smaller. We talked about all that. Okay, so that concludes our development of the Keynesian cross.